Before describing specific landforms created from this chemical weathering type, I'm going to describe the recipe required for it. First off, you have to have a lot of limestone. And so one of the things is limestone's characteristic. It has this mineral calcium carbonate. It's kind of weak. It's very susceptible to chemical weathering. And so one of the things is limestone. We have it all over Indiana. But we have certain areas of our state where that limestone is close to the surface. And so one of the characteristics of karst landscapes is limestone, but also limestone is close to the surface. Further, carbonation. I described carbonation in the previous video lecture section, and so you then have to have carbonation. So in Indiana, because we have a good amount of precipitation, we're going to have more likelihood of that rain picking up CO2 in the atmosphere or the soil. And so that's the second key ingredient. Third, it takes a lot of time, and so this is a very, very slow process. Here we have a tombstone that uses limestone. Why would they use limestone? In Indiana, we see these in old cemeteries. Why would they use limestone? It's the rock underneath them. And so if you're going to memorialize someone, you're not going to use a tree, you're not going to use some twigs, you're going to put down a stone. But one of the things this illustrates, though, is chemical weathering. And so this is a cemetery in which people, most of the other people in this area died in the 1850 to 1890 range. So we know that this is about 130 years of chemical weathering that's slowly eaten away at this limestone. And what this does is shows two things. It shows the time it takes for chemical weathering to occur, but it nonetheless also shows chemical weathering and how it slowly eats away at this underlying bedrock, in this case limestone, that's very much exposed at the surface now that we have it sticking out of the ground. Now let's take that same idea with the tombstone and relate it to our underlying bedrock. And so here we can visualize the carbonic acid being the pink stuff. And so we have cracks in the limestone. How are we going to have cracks? Why are we going to have cracks? Plate tectonics can create cracks once you put push on something or also relieve the stress on something. Also, various heating and cooling back and forth, freeze thaw, can also create cracks. And so over time, these cracks, they widen because that carbonic acid slowly eats away and it goes in those joints, those cracks, and slowly widens them over time. Keep in mind it takes a long time for this to occur. This does not happen overnight. These cracks within the underlying limestone, they get bigger over time as that chemical weathering, as that carbonic acid slowly eats away at that calcium carbonate rock, the limestone rock, that's susceptible